Hello students, in this session we are going to see about balancing. So balancing is nothing but the various forces which act on reciprocating parts of the engine. The resultant of all the forces acting on the body of the engine due to inertia forces is known as unbalanced or shaking force. Thus, if the resultant force of all the forces due to inertia force is zero, then there will be no unbalanced force. But even then, an unbalanced couple or shaking couple will be present. So, the force required to accelerate is given as Fr, where Fi is the inertia force due to the reciprocating parts, and Fn is the force on the side of the cylinder walls, and Fr is the force acting on the crankshaft bearing. Here we can see Fr and Fi are equal in magnitude but opposite in direction, and Fb is the horizontal component. Fbh equal to Fu, which is the unbalanced force. Thus, the purpose of balancing of reciprocating masses is to eliminate the shaking force and the shaking couple. In most of the mechanisms, we can reduce the shaking force and shaking couple by adding appropriate mass, but it is usually not practical to eliminate them completely. In other words, the reciprocating masses are only partially balanced. Next, we are going to see about the primary and secondary unbalanced forces of reciprocating masses. Consider a mass m of the reciprocating part with a length L, radius r at an angle theta with an angular speed omega and the speed ratio n, rotating in a clockwise direction. The accelerating of the reciprocating parts can be found out using AR equal to omega square r cos theta plus cos 2 theta by n. Similarly, Fr equal to mass into acceleration, it becomes m omega square r cos theta plus cos 2 theta divided by n, which is the force. Unbalanced force Fu equal to m omega square r cos theta plus m omega square r cos 2 theta divided by n. So, the ultimate force is Fp plus Fs, where Fp is the primary force m omega square r cos theta, and Fs is the secondary unbalanced force m omega square cos 2 theta divided by n. Please note these 5 points. When Fp is max, take m omega square r, the value of theta is 0 or 180 degree, and when theta is 0, 90, 180 and 360, the secondary unbalanced force is maximum, which becomes Fs max m omega square into r by small n. When we see the secondary unbalanced force is 1 by n times the primary force, the unbalanced force due to the reciprocating masses varies with magnitude but constant in direction, while due to revolving masses, the unbalanced force is constant in magnitude but varies in direction. The partial balancing of unbalanced primary force in a reciprocating engine is given as follows. We know that centrifugal force due to mass B is B omega square small b from this diagram along this direction, and the horizontal component is B omega square cos theta, which is the horizontal component, and this is the vertical component. The primary force becomes B omega square B cos theta is equal to m omega square r cos theta, or BB equal to mr. As to compromise the fraction C constant, the CMR equal to BB. So final formula to find the value is m omega square or root of 1 minus c square cos square theta plus c square sin square theta, where m is the mass of the reciprocating parts and c is the fraction of the reciprocating parts to be balanced. Next, we are going to see about the partial balancing of locomotives. Consider a locomotive having two driving wheels and the engine is placed at the center. We call it as inside cylinder locomotives. When the engine or cylinders are placed up beyond the wheels, the driving wheels, if they are the center, they are called as outside cylinder locomotives. This is the diagrammatic representation for inside cylinder and outside cylinder locomotives. The effect of unbalanced primary force along the line of stroke produces: first one, variation in tractive force along the line of stroke; second one, swaying couple; and third one, hammer blow. These are the effects of the unbalanced primary force along the line of stroke. So variation of tractive force includes: the tractive force is maximum or minimum when the theta value is 135 or 315 degrees. We get plus or minus root of 2 into 1 minus c m omega square r. This is the straight line and this denotes the crank, and this is the connecting rod which moves the mass along the straight line. Second one is the swaying couple. To find swaying couple, we should know what is meant by swaying effect. Swaying effect above the vertical axis tends to sway the engine alternately in clockwise and anti-clockwise direction. Hence, the couple is called a swaying couple. The formula to find swaying couple is plus or minus a by root 2 1 minus c m omega square r. Thus, the swaying couple is maximum or minimum when theta is 45 degrees or 225 degrees. Third force is the hammer blow. The magnitude of maximum value of the unbalanced force along the perpendicular line of stroke is called as hammer blow. The formula to find hammer blow is b omega square b sin theta, maximum when the sin theta is 1, or that is theta equal to 90 degree or 270 degree. When theta is 90 or 270 degree, the hammer blow will be maximum. Net pressure on the wheel of the rail is P plus or minus capital B omega square B. So these are some of the objective type questions given to find the forces along the reciprocating parts of the engine. So first is the primary unbalanced force is maximum when the angle of inclination and the line of stroke is either 0 degree, 90 degree, 180 degree or 360 degree. The answer for this is given in the last, and we got these questions from the books Ratan Tata, Theory of Machines, 4th edition, Tata McGraw-Hill 2014. Thank you.